Okay, we're back with the Tracker 2072 blind duck. This is kind of in the middle of the hull reinforcement. You can see I'm partway through. I've started in the back and I've worked my way up to here. I still got this much more to do, but I'd take a minute to show you some of the progress. So what I have done is, these were the existing hat channel ribs that went across, and I've added in a piece of a 1/16 inch thick angle that I cut and just kind of welded to both sides of this hat channel, one on this side, one on that side, to reinforce it. And before I did that, I actually, where all the cracks were, I welded all the cracks back together to repair the hat channel, and then added the reinforcement angle on each side. And I've still got a little bit of touching up there to do to clean up some of my welds. And then I started adding these extra ribs. And the way I constructed these ribs, these are just 1/8 inch thick pieces of aluminum angle, and the legs are 1.5 by 1.5 inches. So this part here where you have the lap joint, that's 1/8 inch piece here on top of the 1/8 inch thick hull. But then the spine, because they're back to back, the spine is 1/4 inch thick. And that's what I'm putting in there between all the existing channels. And I got one up here that I've started working on. And I'm just going to show you kind of the process for putting these in. So the first thing I have to do is, I cut it to length, which this is a 6 foot wide bottom boat. So these two pieces of angle are 6 feet long. And then I have to cut a lot of relief cuts here. And this is so that I can bend it a little bit to make it match the curvature of the hull of the boat. And then I come back and start at one end, and I just press it down to where I can hopefully get rid of all the gap and have the metal touching metal. And then I just tack weld it on each of these areas, or each of these parts of the hull in here, and I just tack weld it all the way across, which is actually the hardest part of this whole job, because getting a good fit is just difficult to get the metal to touch. That's hard to get the bend in that angle perfect, and the fore of the boat is curved. So usually I can just add a lot of weight myself is the weight, and I just am able to press down on it, then tack it while it's touching, while it's together. Sometimes I have to actually get a jack under the boat, and I'll have to jack up the floor just to try to add some upward force from the below while I'm pushing down to try to get it together. Then once I get it tacked, then the next step, I'll just move to this one that's finished. The next step is I just come in and weld as much as I can, across all these things. This is an intentional gap here for drainage. But, see, these welds some of them are getting a lot better. I still got a lot of room for improvement in my welds, but I just go and weld it all the way as much as I can. You can see here, this aluminum really distorts once it starts getting hot. So even though this started with no gap in here, it started getting a decent sized gap. Same on this other side. There's a decent sized gap between the hull and the rib. So I did not weld that together, just left it. I don't think it really needs that much there anyway. So once I get it all welded to the hull, then I'll come back and just weld the two legs of the aluminum together. So I just do one long continuous weld 6 feet from end to end to weld these two pieces of angle together. And then I also come back and weld all those relief cuts to, give it its rigidity back and fix it in that position. And that's what the final rib looks like. So you see with this one, I still have to come back and you have to clamp this together, so then I can weld it together. And of course I got to finish welding all this. But this whole project takes a long time. It's just a lot of welding. And I just have air-cooled torch, WP17, so that it's only got like a 60% duty cycle at the 140 amps, which is what I usually have to use to weld this. So I have to spend a lot of time letting things cool off before I can keep going. But that's what the interim progress is going to be. Just a quick note, I was trying to read about how to construct the best and strongest rib, and I guess these hat channels are pretty good. U channel is supposedly the strongest. Look at these engineering websites, and they talk about this measure called a section modulus, which is just a measure of the stiffness. So U channel is the best. C channel is a little not quite as strong because of some of the beveling. It weakens it, even though it looks pretty much like a U channel. Hat channel is good, which is what this is. And then T joints or T bars, which is what I'm basically building from scratch as a T bar. Those are weaker than all of those channels I mentioned already. But the only section modulus I've been able to find for T bar is when each of the legs are all the same thickness. So like this would be 1/8 inch thick, this would be 1/8, and that be 1/8. But when you put two pieces of angle back to back, to where now the spine part becomes a 1/4 inch thick, I can't find data on what the section modulus is on that and just how stiff it is. Obviously it's going to be stiffer than a T joint that just had a 1/8 inch thick piece of aluminum serving as the spine, but I just can't find the answer. The next thing I'm reading that I can do to really strengthen this up, if it's needed, is if I were to somehow just connect all this together. So basically, somehow connect this channel to that spine to this channel, it would keep this spine from being able to bend either way this way, when it's under stress. I don't know if that's going to be necessary. I think this is just a lot of reinforcement. But again, it's just, a 6 foot flat bottom boat or 6 foot wide bottom that's pretty much flat, and it, doesn't handle chop and waves and all that really good. It adds a lot of stress, a lot of, just doesn't cut through the water. Okay, that's the update. And I'll let you know when I've got this part finished.